Hi, Michelle Glass here. Welcome back to Chapter 23, Lecture 23 series. Our topic here is the discussion of diffusion of gases. So we're looking at how that oxygen and CO2 know which way to go, and also internal respiration. So let's get started. Okay, so we've been talking about external respiration, focusing in on that pulmonary ventilation, which, I've said, it's basically just breathing, right? And so what we need to talk about next is gas diffusion. So that's the actual movement of those gas molecules from the alveoli to the blood, from the blood to your tissues, and then, back again. Now, the diffusion of gases is controlled or regulated by two gas laws, Dalton's law and Henry's law. So we've already talked about Boyle's law as it applied to pulmonary ventilation. And so now we're talking about Dalton's and Henry's law as it applies to diffusion of gases. In Dalton's law, we're talking about how in a mixture of gases, each individual gas has its own partial pressure. So if you're looking at air, air is composed of oxygen and carbon dioxide gas and nitrogen and other gases as well. And each one of those individual gases has its own partial pressure. And then Henry's law tells us that gases move into solution based on their partial pressures, and they're going to move from a high partial pressure to a low partial pressure. Hopefully this sounds familiar. It should be feeling very much like concentration gradients and diffusion, because that's what we're doing. The significance of these two laws is that, for us, that oxygen gas is going to move independently of carbon dioxide gas. And this is important, right? Because you already know they're moving in opposite directions. So we have oxygen, coming in and going to the blood and out to the tissues. And then we have CO2 from the tissues coming to the blood and then out of the body. And it's able to move in these different directions because of both Dalton's and Henry's law. Okay, again, just think of this as concentration gradient. So gases are moving from a high partial pressure to a low partial pressure. They're moving with their own partial pressure. So this does allow gases to move independently of each other. When we're talking about partial pressure, pressure is measured in millimeters of mercury. So you'll see that kind of unit. I've left it off of my diagrams just for simplification, but that is described for you in your text. Okay, so here we're looking on one side at external respiration. External respiration is, remember, talking about getting the air from the atmosphere into our blood, basically. And then internal respiration is really talking about getting the gases from the blood to the tissues, from the tissues to the blood. So here we're looking at our capillary bringing blood to our alveolus. So it's coming in from that pulmonary circuit. And notice that the blood is low on oxygen. It has a partial pressure of 40 millimeters of mercury, whereas the alveolus has 100 millimeters of mercury partial pressure. So if our oxygen is going from a high to a low partial pressure, then clearly this oxygen is going to move from the alveolus into the capillary. And that's what we already know to be true, but this is the why. Okay, now let's look at CO2. Carbon dioxide gas in the blood as it's coming through the pulmonary circuit has a partial pressure of 45 millimeters of mercury, but the alveolus has a partial pressure of 40. So again, CO2 is going to move from a high to a low partial pressure, and so we see that it is moving out of the capillary and to the alveolus. So that as our blood is getting ready to go through the systemic circuit, the oxygen has, initially a partial pressure of 100 and the CO2 of 40. We will see as the blood is moving through like the conducting portion of the lungs that we're going to deliver some of that oxygen. So as we actually get into the systemic circuit, the partial pressure of oxygen has dropped a little bit to 95, but that's okay because the partial pressure of oxygen in the tissue is 40. So because our oxygen is going from a high to low partial pressure, it leaves the capillary and it goes to the interstitial fluid. And then notice your partial pressure of CO2 is 45 in the interstitial fluid, and so it's going to go from high to low, meaning it's moving into the capillary. There's nothing super tricky here. I don't really think that we need to memorize these exact numbers. I do think we should know, the Dalton's law and Henry's law, and how this is allowing us to predict the movement of these gases, or explain the how those gases know which direction to move. As our blood is making its way back to the pulmonary circuit, then it's going to have those partial pressures that we've just, moved toward. And so the blood is back to being, or the partial pressure for oxygen is back to 40, and the partial pressure for CO2 is back to 45. So as it comes to the alveolus, then we're going to see that delivery of CO2 and the picking up of oxygen that we've already talked about. Okay, that is it for now.